Hello, in this lesson, can we learn how to use the translation vector to translate figures in the Cartesian plane? And for his understanding, can we use an example to apply the logic of this formula? So, let's say you are given a triangle which has vertices A S2, 1, then B S5, 1, and then C S4, 3. Then the triangle is translated by the vector 3, -2. Then you are taught to write down the coordinates of the translated triangle, which is, of course, A and B and C. So, how do we go about this? So here I've copied the original coordinates of the triangle and the translation vector, which is 3, -2. So here A takes on the value of 3, and then B takes on the value of -2. So in this, our original coordinates, the first value is X in all the points, and the second value is Y in all the points, like this. Then, to translate this original triangle to a new one, we apply this formula. X and Y, they change to X plus A, where this A is the first value in the translation vector, like in our case it is 3. So we'll take all the values of X here and we'll be adding 3, and then Y plus B. In our case, B is -2, so we'll take all the values of Y, and then we add -2. So from there now we can start calculating the translated coordinates. So we can start with translated, where we have X plus A. So we come to point A, where we have now 2, because it's the value for X, then 2 plus 3, because in our case is 3. So 2 plus 3 is 5. Then we go to Y plus B. So where Y in our A is 1, and now plus -2. So it's kind of like 1 plus -2, which is the same as 1 and -2, because positive multiplied by negative is negative. So it becomes 1 minus 2, so it becomes -1, like that. And this one is -1. And then we go to B, point B. And in point B, we have X is 5. And then, of course, we know our A is 3. So it becomes 5 plus 3, which is 8. And then we go to Y, which is 1. But now 1 plus -2, the same story, which is 1 minus 2, -1. And then we go to C, translated, where we have X is 4, but we already know our A is 3. So X plus A is 4 plus 3, which is 7. And then we have our B, our Y, which is 3, but now 3 plus -2, it just becomes 3 plus 2 -2, which becomes 3 minus 2, because positive and negative, it becomes negative. So 3 minus 2 is 1. Others become our translated coordinates of the new triangle here. So you have answered this question. So can we try another example where we are supposed to find the translated coordinates, and then we plot the original and the translated triangle in the Cartesian plane. So in this question 2, you are told a triangle ABC has vertices A is -1, 2, B is 2, 2, and then C is 0, 5. It is translated by the translation vector -4, 1. Then the first question, plot the triangle in BC on the coordinate grid, then plot the image of the triangle, of course, ABC, the one which is translated, and then write down the coordinates of the translated triangle. So we can start with this, writing down these coordinates, then we come to plotting the original one, and then we finish by plotting the translated one. So we have the original, of course, coordinates, where these the first values in each of the points, L represent X, and then Y are the second values in each of the coordinates. And then we have our translation vector, which is -4, 1. Then our formula as usual remains to be xy is translated now to x plus a, and then y plus b, where a is the first value of the translation vector and b is the second value of the translation vector. So from there, we can of course start getting our translated coordinates, and we can start with a. We already have x plus a, and we already know x is -1, and then our a is also -4. So it's kind of like you're told -1 plus -4, which now becomes -1 minus 4, which is -5, because positive and negative becomes negative. So that one is okay. Then we go to y, where we have y plus b, and we already know b is 1 and y is 2. So 2 plus 1 is 3, like this. Then we go to b, where we'll have, we repeat the same process. We have x is 2, then plus our a is -4, so I'm plus -4, which is the same as 2 minus 4, which is -2. So here it becomes -2, and then for y here it is 2, but we already have, b is also 1, so 2 plus 1 is 3. Then we go to c, where we do have 0, then plus our -4, which is now 0 minus 4, which is -4. So this becomes -4, and then we have y has 5, and then we know our b is 1, so 5 plus 1, which is 6. And we have our new coordinates of the translated triangle here. So we have answered this question here, and also this one. So because we have the translated coordinates, so what we are remaining with is just plotting the original triangle, and then we can also plot the translated one. So we can start with the original triangle, where we have the coordinates as -1, 2. So we come in our Cartesian plane, and then we start with the -1, 2. I think we have -1, 2 somewhere there. The second one is 2, 2. So 2 in the x-axis, and then 2 in the y-axis somewhere there. And then we have the last one is 0, 5. So we have 0 for x-axis, but then 5 for y-axis, or somewhere there. That becomes our original triangle. And then we can also plot the translated one, because we already have the coordinates, and the first one is -5, 3 here. So I plotted as -5. Then we go all the way to 3 somewhere there. Then we go back to -2, 3. So we have -2, and we have 3 somewhere here on the y-axis. So like this. Then we go again to the last one, which is -4, 6. -4, and then we have 6 somewhere here. And that becomes the translated triangle. So that's how we go about translating figures using a translation vector. And then we can also do other examples where we are not supposed to plot, but then we are even given like, let me check one. Like for example, in this one, you are given the original coordinates and the new coordinates, and then you are now asked to find the translation vector itself. So can we try to solve this question 3? You are told a triangle has vertices as A 3, -1, then B 6, -1, and then C is 5, 2. Then its image has vertices as the translated one, of course, a 7, 3, then 10, 3, and then 9, 6. And then you are told to find the translation vector that maps triangle MBC onto triangle BC, the translated one. So the first step, of course, let us copy all these coordinates in our board. So now here we have the original ones and then else, and then you are told to find the translation factor which we called b, like this. But look, here the x coordinates, I can call this x for point A, but it was now translated to, let me call it x1, and then this is y for point A, but now it was translated to y1. Then this is x, of course, for original point B, then translated to this one. I can call it x1, no problem. Then this is y, then I can call this one y1, and then this one I can just call it x, then this one x1, then this one y, then translated to this y1, like this. So from there, our original formula was this. We said we have x, y, translates to x plus a, and then y plus b, like this. So in short, it means this x, these values of x, to be translated to this x1, what happened is we took the x, and then we took x plus a to get this one. So if we took x plus a to get this x1, like this, then it means to get our a, we only need to take this x on the other side, so it becomes now a is equals to x1 minus this original x, like this. So we have now the formula for getting a in our translation factor. But then how about b? So in b, we have y plus b, but then this y plus b gave us y1 in all these points. So now that one gave us y1, then it means to get the b itself, I just need to take this y on the other side. So it becomes b is equals to y1 minus y, like this. So I have the value for b. So now that I have the formula for a and b, I can just pick any random point, like for example a, and then I pick the translated a, and then I apply this formula in that specific coordinate and get the translation factor. So in this case, then it will be is equals, our translation factor is for a, then it will be x1, where in a translated x1 is 7, then minus we have our original x, which was 3, like that. And then we go again and apply form b. So form b is y1, specifically on that a, so it will be -1, then minus, but we also have our original one. Sorry, here we made a mistake because this y1 is not -1. It's not -1, it is 3. So just a small mistake there we can correct. So that is 3, then minus our original y, which was -1, like this. So with that now, we get our translation factor is 7 minus 3, which is 4. And then 3 minus 1. Now this negative will multiply with this one, it will be positive. So it will be 3 plus 1, which is 4, like this. As that becomes our translation factor. But just to confirm and be sure it is the translation factor, we can try to apply the same logic to the other two coordinates. So we can start with b, where we have 10 and 3. See if actually we'll get the same translation factor, because all the coordinates here must be translated by the same translation factor to here. So if we have, let me say, we have b, which is 10, if, of course for x1, then minus x, which is 6, like that. Then we have then b, which is y, of course, which is y1, which is 3, and then minus our original y, which was -1 on b, like this. So it becomes 10 minus 6 is 4, then 3 minus 1, it will still be 4. So B is okay. So we can try C again. As it will give us the same answer. So we have our new translated x1 is 9, then that 9 minus our range of x, which was 5. Then we go to the second one, which is 2, and here we have 6. Then so we have 6 minus 2, which now becomes 9 minus 5 is 4, then 6 minus 2 is 4. So all the 3 points are translated by the same translation factor. So can you try to solve this question 5 and question 6, and you see if you understand the logic. If you don't, you can ask me any question. I try to solve it to my level best on the comment section. You can also subscribe to this channel so that you keep getting mathematical content like this. And bye for now. Let us meet in the next lesson.